Alright friends, so in the previous video we talked about the basic Solow model where we did more conceptual wise things. Now in this video we're going to talk about the question number second, which has the function, production function, and the saving rate, the depreciation rate, and it's asking the capital labor ratio at the steady state. Now there is a new term called steady state, and we'll be talking about that in the process. Also in B 2B it's asking what is the output and consumption per worker at the steady state. So mostly we'll be talking about the steady state in the basic Solow model. Again, the main topic is basic Solow model. Perfect. Now the given function, production function, is the function of capital and time t, and then labor, and the population of time t, which is equals to k power 1 by 2 kt power 1 by 2 times nt power 1 by 2. And from this function also what else is given is saving rate is equals to 30%, that is 0.3, and then depreciation rate equals to 10%, which is 0.1. Now we know that this is the total production function, but like per capita production function y, which is small yt, is equals to we can write that as small kt power 1 by 2. Now if you don't understand how it came, then go back to my first video. Okay, let me turn it on. Alright, if you don't understand how it came, the per capita production function small yt equals to small kt power 1 by 2. If you don't understand how it came, then you just go back to my previous video in the basic Solow model first video, then I'll explain it over there. Now we also know that per capita capital accumulation function, which is yt plus 1, is equals to from the previous one we know that yt plus 1 is equals to sorry about that, actually kt plus 1. I'll prefer to explain it or derive it right here. So we know that capital yt plus 1 over nt plus 1 is equals to the function of kt plus investment it minus depreciation d of kt over nt. Here nt plus 1, I'll just replace nt plus 1 by nt plus 1, and here I'll do nt. So if you cancel, we just get the same thing. So further we get so from here we get small kt plus small it minus small d small kt times, here in the basic Solow model we also always consider that small t the population in time t and population in time t plus 1 is always gonna be the same. Yes, you can see it right here. So if both of them are same, then it cancels out, and then we get n here by nt plus 1 to be 1, which we don't write right here because we multiply this and get the same thing. However, this IT is S times YT, which can be written as small kt plus S times and YT, S times YT, where YT is KT power 1 by 2. So it's KT power 1 by 2 negative dkt. Okay, all right. So this is our per capita production function. Now the question is asking that what is the capital labor ratio at the steady state? That is, what is what is the value of KT at the steady state? So we know at steady state, if the economy is at steady state, then YT plus 1 is, wait, hold on, here, it's gonna be small YT plus 1. Oh, actually here, my bad. Actually, this is KT, sorry. So it's gonna be, capital KT plus 1 by NT plus, So it's gonna be small KT plus 1 is equals to capital KT plus 1 over and capital NT plus 1. So at steady state, KT plus 1 is gonna be equals to KT. That means there is no change in the per capita capital accumulation, per capita production. That means if both of these are equal, then from this equation, KT plus 1 equals to KT plus SKT power 1 by 2 minus dkt. We get that SKT power 1 by 2 is equals to dkt. So this is the main relation at steady state, which implies if we put the values whatever we have been provided with, we get that S is equals to 0.3 KT power 1 by 2 is equals to 0.1 times KT. Now, if we solve for KT from this, we'll get KT is equals to 0.3 over 0.1 is 3, and then if we subtract it, we'll get 1 by 2, so squared equals to 9. So at steady state, the capital labor ratio at steady state is gonna be 9. Now in second question, we have been asked to find the output and consumption per worker at the steady state. That means we have been asked the Y value for YT, small YT, is the production per capita, and also the consumption per worker. So let's find the YT per person, where YT is KT power 1 by 2, which is small kt power 1 by 2, which is equals to 9 power 1 by 2, that is 3. Right? All right, so we got that the consumption per capita is 3. Consumption equals to 1 minus saving times. Okay, and we also know that the consumption C is equals to the consumption is equals to the production minus production minus saving, which is S times YT. Actually, S times YT, which is equals to, we can also write 1 minus saving times YT. And here we know that saving is 0.3, so we get 0.7 times YT, we know that, which is 3, so we get 2.1 to be the consumption, and that's our final answer. All right, hopefully I did explain it in a clear way. We'll see you in the next video with the next problem solving. All right, take care. Bye bye.